Hello everyone, my name is Joe Scorson, the channel is called Ethernet Link, and in today's video we have the third Advent of Code episode. We're going to be building on last episode's code a lot. We're really just going to add a function and then 2 more lines, 3 more lines, 4 more, 4. I think if you really want to get technical with the function, the 4 more. Kind of more actually, I'm not too sure. Not important. But yeah, this episode we're going to be talking about volatility, and I think that this is an incredibly important topic to talk about, especially because my next few videos are going to be about options. So you really have to understand volatility to understand why option prices move the way that they do sometimes. So yeah, without further ado, let us get into it. Before that though, this is my business Twitter. I'd really appreciate if you guys check this out, give it a follow, get it to 100 by the end of the year. Just do that, that'd be sick, right? And this is my indicator I made in collaboration with LuxAlgo. Link to this will be in the description, and there are videos on my YouTube channel about backtesting this. You guys could download this, not download it, you guys could subscribe to it, and then you just have access on your TradingView accounts. You can put it on your charts and then trade with it. 40 bucks a month. Not too bad. Yeah, let's hop right into this code though. So we can see actually that this file is pretty much the exact same from episode 2, right? We're just going to be pretty much adding to it. We're just going to be adding some volatility. So this task is to get data with the second episode's code we wrote and calculate different kinds of volatility on it. Use standard deviation of log returns, EWMA, and annualize the standard deviation of log returns. Use subplots to plot every volatility. Cool. So let's get into it. Let's just make our first function, which would be calculate volatility. We just need our data for that one. Next, let's get our log returns. So this will be to np.log. Then we'll have to get data, not those brackets, close, and then put that over the close before it. So data close and then shift it 1. So dot shift 1. There we go. Just want to make sure I did that right. Next, we're going to say data. Then we're going to have our rolling standard deviation. So rolling standard deviation is going to be our log returns with a rolling window. I'm just going to hard code it to be 20. So it'll always use the past 20 bars. And then dot standard deviation. Next, we're going to get the EWMA's standard deviation, so the exponentially weighted moving averages standard deviation. So again, exact same thing, but instead of rolling, we're going to say dot EWMA. Cool. And then we want to annualize this rolling standard deviation. So data annualized vol is going to be our rolling standard deviation times np dot square root of 252, because there's 252 trading days in a year. And then I want to say, oh, actually, I forgot to even add this because I forgot to change this. So just make sure that you have a data equals data dot drop NA, right? Always want to do that. So bear with me as I apply that. So then we want to return our data. So just make sure that you always drop those NaN columns, especially when you're doing calculations with rolling windows, because you'll always have NaNs after that. And we don't want those. They're not useful. So now that we have that, let's just go ahead and get data is calculate volatility with our data. And then I want to just print data dot head just to make sure all that worked right. So now just run our file. I did mean that. So come up here, EWM, not EWM, not EWMA, and got an unexpected argument. So, oh yeah, it's span, not window, it's span. clear that once more and then run it again. There we go. And we have our columns right. So we have our log returns, rolling standard deviation, exponential weighted moving average standard deviation, and our annualized volatility. Sweet. So now we can clear that, make it a little easier on the eyes, and now we can just plot it. So make sure that you set your rows to be 3 and you change your heights, add another title, and then you could head down here and you could just add the volatility as follows. So you could come down here and you could say something like fig.add trace with scatter plot, and then just make sure that you have the right kind of thing in the data frame, right? So we're gonna have the EWMA standard deviation, then annualized vol down here, and then change the name as well. Cool. And so now let's get rid of this print, and then let's plot everything again. And then we're really going to be talking about this. That'll be the most important kind of things. Those aren't errors, don't worry about it. And so here we are. Full screen this for you guys. And yeah, so here we are on Apple. And we can see that now we have our new subplot down here for our volatility, and we have all of them. So I'm going to get rid of this, that way we can see this a little bit better. And then we're going to get back to it. So now we could see the different ways to calculate volatility pretty much, and we can see that just when things out of the ordinary happen, like right here on June 11th, we can see that just when things that are out of the ordinary happen, the volatility tends to go up. Let me try to find one that had a big dip. Yeah, right over here. I just want to add that again because I'm gonna, yeah. So we have this big dip right here, and we can see that the volatility pops with that as well, right? And so now, just looking at this volatility chart, right? We're going to start talking about options a little bit. Just looking at this volatility chart, with the rolling standard deviation, the EWMA standard deviation, or the annualized volatility, if I were to price options with each of these, which ones do you think would be the most expensive? I hope that you said the annualized volatility, because it simply is the bigger number, right? If I were to take that away, which ones would probably be more expensive? Probably the rolling standard deviation of log returns, right? Now, this is a really important thing to understand when you price options, is that the volatility changing can affect your option in a way that price won't even affect it sometimes. If you guys ever heard of IV crush from earnings, right? This scenario, this annoying one, I've been in it before. It sucks because when you're right about the direction the stock will go in, but you lose money on your contracts. So the way that that would work is, let's say that there's an earnings event. Earnings events are very volatile, and the market knows that. So leading into an earnings report, the implied volatility in option will go up and up and up and up as you get to the earnings date. Company reports earnings, all of a sudden the volatile event's done. All that juice, all that VIG, whatever word I need to use to get you to understand it, I don't know if you were a bookie before, all that juice, all that VIG leaves the contract. And now, even though you were right about the direction, let's say you had calls on a company that gapped up 6% for earnings, you could still lose money from that. Let me take a sip of water. Because after that event, the implied volatility might drop. I don't know if this was an earnings event right here on Google on July 6th to 7th, right? But even if I had, let's actually take a look at this, right? And I'm going to explain it like that. So where are we? So now let's say if I had a put, excuse me, let's say if I had a put right here. Let's say I had a put at strike 121. Excuse me, I have such a, my voice is so hoarse, I've recorded a few of these by now. Excuse me. So let's say you hit a put right here with a strike at 121, and then this low was at 118. You would have still made money because they would have moved intrinsically. Right, so now let's even talk about a different kind of scenario. And let me not cough all over the place. Okay. So, let's say you had a strike at like 115, right? Really out of the money. even though it did drop, this IV dropping or this is the volatility dropping, the IV could still stay jacked. Excuse me, but this volatility dropping is not good for your contract's price, right? Regardless of the direction that you were trading it in. Volatility dropping really means that the thing that's partially used to price your contract is also dropping. So that concept is super important to know about. We're going to talk about it more and more when we actually price an option. We plot premium over here because we're going to do it with these different volatility metrics, and we're going to see which ones, excuse me, which ones yield a more expensive premium, even though the rest of the inputs will stay the same. And then implied volatility estimates, we're going to get into that a little bit later. I also have other videos on my channel if you don't want to do it in Python. Regardless, though, that's this video. That's episode 3 of the Advent of Code. We calculated our volatility, we plotted it, and we spoke a bit about what it means, and then kind of loosely how we're going to use it in pricing options. Of course, we're not pricing options right now, so I'm going to save it for when we do. But you know what I mean. I hope that you guys enjoyed this one. I hope that you guys are looking forward for the 4th one, when we're going to actually start doing some really, really interesting things. I'm looking forward for the data structures one. I want to show you guys about the async cache that I made. This is nothing revolutionary. I didn't come up with this concept, but I just think it's so cool. But yeah, I hope that you guys have a good rest of your day. Hope that you guys are enjoying this Advent of Code so far. And yeah, I will see you guys in the next video when we start to talk about options. Have a good one.